Hey everybody, we are going to talk about converting polar coordinates to rectangular coordinates. Whoa, hey. And rectangular coordinates to polar coordinates. Now first off, we're going to talk about a rectangular coordinate. So, we're going to go rectangular to polar. Now, let's say we're in a coordinate plane. I got a point right here, that's xy. And so there's my point. Let's zoom in a little bit on there, because you don't need the title anymore. We just need this. All right. So now what I want to do is I want to find my theta. I need to find that theta right there, and I need to find that r. But what I know is xy. Now, the nice thing about this, let's try to make this a little bit clearer. There we go. Is if I created that little right triangle there, that's my y, that's my x, that's all I need to know. Because I have a Pythagorean theorem opportunity here. I have x squared and y squared, r squared. R squared is equal to x squared plus y squared. Just from the Pythagorean theorem, so r is equal to the square root of x squared plus y squared. Now r is going to be positive no matter what, because r is just a value here. In the sense we're just finding our theta right here, we're going to be okay. Now, the things that we know are x and y. So, if that's theta, I know an opposite, I know an adjacent. So I'm going to use a tangent. So, theta is going to be the inverse tangent of y over x. Now, there's going to be points where you're going to have a measurement over here, you're going to get a theta, you're going to get a reference angle, you're going to get all sorts of fun stuff like that. You're going to have to make a determination where in the coordinate system we are and what theta is actually going to be, so you're going to have to kind of draw some pictures and go from there. But that's the basicness of the measurements that we have. So now, if we go polar to rectangular, this is even easier. Here's what we got. Say I know r and I know theta, but what I want to find is x and y. And again, use the triangle. That's y, that's x. Now, that's an opposite side, so in order to find y is going to be equal to, well, first off, we won't say that. We'll just say sine theta, because that's the opposite, and I know the hypotenuse is equal to r over y. Alright, my brain's locked up a little bit. It's y over r. Duh. That's the hypotenuse. That's the side. Multiply both sides by r. You get r times the sine theta is equal to y. Alright, production value on this one's pretty low. Now, similarly, you have the adjacent side here, and you have the hypotenuse, and you have your angle. So you can say that the cosine, because we have adjacent over hypotenuse, cosine theta is equal to x over r. Multiply both sides by r. Get r times the cosine theta is equal to x. So therefore, if you have r comma theta, you can transform that into r cosine theta times, comma, r sine theta. So those are the two basic ways, let's zoom out a little bit, of figuring out your polar coordinates. Now, we did a little exercise, the calculator. Now, to take advantage of the calculator, not quite sure how this is going to look on the screen here, so hopefully we got some goodness going on here. It's not too bad. We're going to use this key, the book key. So, you need the book key, which is going to be 2 from the 9. 2 to the right of 9. Now, get in the calculator screen, and the functions that you're going to use, if we're in the book, let's do this. Let's move that up. Make this work a little bit. We have 2 right here. These 2 right here. R, arrow, P, theta, then parentheses. And in the parentheses, you can see x value, y value. So this is going to be xy. And then we'll have R, P, R, xy. This is going to get you theta. This is going to get you your R value. And xy is just going to be your coordinates. Now, depending on what your calculator setting is at, your theta will either come in at radians or into degrees. But remember, you can also convert to radians if you're in degrees, or if you're in degrees you can convert, or if you're in radians you can convert to degrees. So that's going from rectangular to polar, and we can go polar to rectangular by using the book again, and all you have to do is hit the P key, and you have PRX, PRY, so we have P, that's going to give you your x value. If you have your polar coordinate, RY is polar to rectangular, and you still need to put in R theta, and it'll give you your y coordinate. Now, be careful. If you're putting in this as a degree, use the pi key, and then select the degree key. If you're using this as a radian, use the pi key, which is by h. And then use the R key. Now, I'll give you a brief demonstration. Say we have a polar coordinate and I wanted the x value. So I'm going to hit enter. And I need to put in, let's say we're at 6, comma, and we're at 250 degrees. I'm going to hit, right down here, I'll hit pi. Oh, escape out of that. I'll hit pi. I hit pi there. And we have all these different values. This is the degree key, that's the radian key. So I will move down to degrees and put that in there to ensure that my calculator knows that I'm working with degrees. Too few arguments. Oh, it happens. I put a parentheses instead of a comma, and there's my x value. Now if I wanted to put the y value, I'll move down to y, and 6, 250, and then pi degrees. So I know my coordinates are going to be negative 2.052 and negative 5.638. And we can round them to whatever places we need to. Now, if I'm in radians, I'll use the radians that we know. We'll use 90 degrees because we know that the x value will be 0 and the y value will be a little bit different. Actually, the y value should be r. So let's try that. I want the x value, so I'm going to go PRX, and let's say I want 5, 90 degrees. And I got a 0, which makes sense because to find the x, the cosine of 90 degrees is 0. Now if I want PRY, 5, 90 degrees, I got a 5. Ended up working out just the way we thought it would. So those are some really nice ways to figure out and convert using a calculator. You are going to be responsible for doing things by hand and doing things by calculator. So enjoy!